And first of all, I want to remember these people who helped me to understand better science. Is Bodenheimer, Rosen, Warburg, Navet, and Swirsky. And these people did different things. Someone was entomologist, someone was taxonomy, someone was ecologist, landscape ecologist. And a part of my appreciated book is this one. The origin of agriculture is here in this land, you say. And what we eat today, what we speak of, come from this land. And the soil you have is the marvelous soil with the activity, biological activity inside that has to be studied more convincingly now, because it's a transition to the future. And I continue to modify my presentation, really, after the travel of yesterday. And I have about 200 slides. Don't worry, I don't present all the material. But I want to give you some idea, maybe some point of reflection and for discussion and for having better exchange. I thought to come here, to come and understand and learning from you, and not to teach you anything, you say, because you don't need my talk. You have yourself, in your tradition, a lot of information, a lot of stimuli we heard before, and I'm here just as a friend who try to enjoy with you some part of my work. This is the first question. Which plant, which animal? Separation from natural and rural landscape, or we maintain mosaic, tillage, mulching, rotation, redesign the landscape, introducing new elements like hedgerow, woodlot, and too much devote our effort towards GMO, genetically modified organism, or invent new crop, or, as I did and suggested, to look at mini livestock. That is things that maybe we are not used to eat, but we could eat in the future, or we could partially consider as possible resource. Our question for everybody. This lady in the Andes produced different varieties of potatoes. She has not been to university, not any center of research, but she maintained the diversity of crop. If today we can eat potatoes and continue to improve varieties in Holland, or maybe here, or in the United States, it's because these people, for centuries, for thousands of years, has devoted his effort on wild relative of this crop. You see, varieties, different varieties, maintain important feature for the future and also for eventually GMO or whatever you think is better for agriculture. Again, you see, for us, if I say insect to my student, I say it's good insects. Insects are useful, what you think about insects. The word insect for you is good, bad. Parasite. We are terrified by insects normally. Children learn from the mother, from the parents, don't touch that. It's dangerous. And when we speak that insects are good, we are speaking of something we are not convinced. Because say, bees are very important. They produce honey. I like bees, are important insects. But go close to them. Maybe they are biting you. Then insect has not a good relevance in our thinking as potential food for the future. As I try to summarize in this book, coming from all parts of the world. You see terracing here in the profile of this mountain. We are not in the Dolomites, but we are in Ethiopia, in the highlands, and we see this terracing. And all the terracing has been deleted by the time. This was an agriculture very important. Now there is only isolated large tree, ficus, I think, one here, the other there. And you can see the color of the soil. On the left, you see lateritic soil, but under the tree, there is a different kind of soil, brown soil. There is organic substance. There is life, different life in this soil. Most of our soil, after thousands of years of agriculture, became of this color red, you say, become poor of organic substance. And having vegetation means having possibility to have life in the soil. And life in the soil is very important. You can see here two kinds of plantation. One traditional of chestnut on the left, a Pinus strobus or Pinus radiata. That's rapid growth Pinus american, introduced into many countries, including Italy. The soil under Pinus strobus is like cement, like here, you say. And the left, you can see a huge amount of cast, especially of worms, but not small worm, the big one that are important to produce air inside the soil and introduce water appropriately in the soil and reducing erosion. This is the best. This is the botanical garden of Rome. You saw all botanical garden and the place in which the tourists go and say that a nice tree, nice flower. And there is part of the botanical garden where the people doesn't go, and this is one of the parts. And this soil may be established, not disturbed, since 15th century. And here you have the example, possible projection of what was a soil in this area, in Rome area, 500 years ago, and I think maybe 1,000 years ago, 2,000 years ago. You know what is the key of this soil? Is two species of earthworms. One of these is being indicated to live also here. We'll see later. You see this soil? These are from eastern part of Istria. Istria is now not under Italy, but is a new country. And the profile, the first and second profile, representing the forest that still is there, of living big earthworms. In this kind of soil, truffles are collected today. And not in the two profiles you see on the right. In this profile, you don't see these big earthworms. And here you can see the big earthworms. We call anesic, species that stay in gallery very deep, maybe 1-2 meters into the soil, come on the surface only when it's very wet, and maybe in spring or autumn, and come in the surface only. It's very difficult to collect them, very difficult to see them. And what about vineyards? In Italy, you can find all this kind of vineyards. Yeah, from this situation, this is an organic vineyard, this also organic vineyard, to a situation in which you don't want any wheat. You think that wheat is a problem because they subtract nutrients to the grape, because you think that it's always it's not clean. You say they want to see clean, no leaves, no vegetation in between the row. But it's completely different to have a landscape with this kind of situation or this kind of situation. And what is used normally, I think here and there, is Roundup. You know what is Roundup when you speak of earthworms? You lose about, if you're happy, you reduce 50% of the population of big earthworm in the soil. And if you are not bad, you lose 60%. And what you do when you are organic, you like to see plants living inside your system. In the spring, you have a cover crop, and you have this situation. And you have occasionally this kind of rabbit beetles eating slugs, but eating also different parasitic butterflies that can affect your system. In different parts of the world, we are in Australia, they use straw. Here, they use to plant oat. And there is a very interesting trifolium subterraneum, that respond to the farmer. They say, but the weeds are competitive with my grape for the water. Trifolium subterraneum, when it's dry, introduce the flower into the soil, and then introduce the seed into the soil that will germinate the next spring, and then reducing competition for water. This is a Mediterranean species that has been found also, I think, in this country. And if you like to see that, the seed comes from Australia, because the genetic has been developed in Australia, not in our countries. And I try to explain my interest in agriculture started from a problem. This problem was spider mite in corn, soybean. In this year was a terrible invasion of this guy. Was a terrible invasion, and as you see here, the corn was completely dry in July, and the cobs was very small, and the farmers were very upset. When the farmers are upset for a pest, Institute of Entomology increased the position. It was Ohio State, and the chief told me, when we get European corn borer in this institute, we were 3 persons. After the invasion and the problem, additional 10 people was enlightened for the system. In this case, people asked me to look around and see how this pest is so dramatic in monoculture of corn. And the response was the problem was related to vegetation around the field. The hedgerow, the alfalfa, or any kind of different vegetation in the system. What happens? During winter, some predators stay in the hedgerow. In spring, they move little by little in the fields. Also, the target pest, spider mite, go in the field, but is controlled since the beginning by some predators. And this is small beetles was the first time that was indicated to live in Italy. Only because we demonstrated that it's a very good predator, the adult and also the larva. But the story is more complicated. In this occasion, we found a family of gamma-zit mite, Lelapide, that was never in the literature indicated as a predator of spider mite. And Karg is a colleague of Germany, described 3 new species of our collection. And see here, this is soybean fields. The one on the left without any hedgerow in proximity, and you see the color that these patches, very light color, is where the spider mite attack. And here with the hedgerow, you see not more light green, a very limited attack of spider mites. But there is another small story that I'd like to speak with you. This is maple, edge maple, and this is grape. You see, this kind of cultivation has about 3,000 years. Before the Romans, this kind of strategy was used by population living in central Tuscany. You still see some places, Tuscany, some maple sustaining the grape. This was common until the Second World War. After, in the 50s, the 60s, agronomy said this is a competition with a grape, produce shadow, is labor intensive, eliminate and put a concrete stick or iron or whatever. But this plant produce domatia. Domatia are sort of small houses that are colonized by predators. These are the predators. Phytozoidae is a family of mites that here in Volcani have been studied by Zwisky. Then you had the taxonomist of this family. Very good. And these predators are very active to control spider mites. And in this area, we have 28 species of phytosaid, not one, 28. And are common in different plants. Maple is the one who bears 18 species, and Urtica dioica, stinging nettle, about 14. Then there is transfer of phytosaid from different kind of vegetation. These are the four more abundant. But you see, if you have the phytosaid in the grape are common with the elm, with the maple, with soybean, with stinging nettle. And stinging nettle is very important exchange with the hedgerow. Yesterday I was in a tour and I was looking around your landscape in the Galilee, and I couldn't see any kind of hedgerow. And I thought, tomorrow I will speak of hedgerow to people who have not seen hedgerow in this country. And they say, they will argue that it's completely false what I'm saying. And the climate is different. The situation, traditional situation of farmers is different, as we heard before. But the idea that diversity of plant close to the crop can provide some good predator parasitoid useful for the production is very important. And it's the idea that has to be transmitted. Not, I say, tomorrow I try to plant hedgerow. I think here it's very difficult to plant hedgerow. But you have maybe traditional vegetation, like the oak, like other leguminous tree or plantlets. And these are maybe the starting point. And you say, we have resistant plant for maybe an insect, and suddenly arrive this isopod. We are in Australia, and this isopod distracts cereals. Nobody thinks that in Australia, species that are Australian can provide damage to crop. Normally are foreign species, introduced species that create problem. This is a case in which local species create a problem. But you know, we studied this problem in Victoria and in Eastern Australia, and we found that one of the reasons is the transformation of the landscape. You have not any natural vegetation, no mallee. Mallee is a sort of wood vegetation. And then these animals that live only generally eat litter. They don't find litter, and they try to eat the wheat. And then we found that it's very important to measure the biodiversity of the different environment, to compare biodiversity of existing lot of wood, vegetation like pasture, and vineyards. This is a work we did in Victoria, Australia. And this is my student, PhD student. He was not so much convinced, but when you ask people to scratch in the soil, they don't like so much to have the dirty hands with the soil. And in our university, there is more position for water scientists, biologists working in water, fresh water, marine water, whatever, than for soil scientists working on soil and soil animals. And the situation, this is again Australia, Victoria, is to have 10,000 hectares of one crop, grape, and one big canteen like that. And we ask, this is the only way to produce wine? Maybe it's a good way to produce one kind of wine in a system which is very abundant in landscape, but is not the best. It's a huge. And I asked my student, in Italy we found this beetle. I'm sure that you can find here. They said, no, it's not possible, never seen. Because the dimension is 1 millimeter. You don't expect to find a predator of 1 millimeter. But after 6 months, they sent me this guy here. And this is not exactly the same species we found in Italy, but is another species close to it that live in the tropic and was occasionally in the vineyard. But the vineyard without any vegetation except some herbs near the road are very little amount of these predators. But some predators are living there, like these phytosaid that live on these mites that are alternative food for them when they live here. Then organic systems are in general plenty of vegetation. You say this is, I think, this is planted vegetation. And occasionally you can see aphids, parasitized. You see the hole from which an aphidide, Hymenoptera parasitoid, has been exit. Then when we look at agriculture, we think we have to look to system in which you have crop, but you have also environment. You have natural vegetation. It's the only way to produce an ethical component of the landscape. And I don't know if my time. How many minutes?
Like 20, 15.
Yeah. This is the earthworms. I'm being presented as an entomologist, but entomologists, they say, move in different direction. And you cannot study soil without earthworms. And I want to remember a story that is Darwin, Charles Darwin's story. Maybe you know that the last book of Darwin was on earthworms. He was the most important biologist of the last century. He was famous, but the last book, 1882, was on earthworms. And the earthworms, he said, are being created to plow the soil, to be a sort of system moving the soil and producing the quality of soil through the humus production. But Charles Darwin forgot to identify the earthworms he was studying in his house garden. And he doesn't speak of this one that produced vertical gallery, that is a anasic species. What does it mean? That produce gallery, deep gallery, and come to the surface when the condition permit it to eat some litter. Then are eating litter on the surface, but are producing deep gallery. Lumbricus terrestris, the species who studied Darwin, produce gallery deep up to 3 meters on the soil. And these deep burrowing species or anasic species can be bigger than all the worms that normally we have seen. Why people said, never seen this bird? Because these earthworms are very difficult to see, because live deep into the soil, come on the surface only during the night, and Lumbricus terrestris collect the litter, or in the vineyard collect the small pieces of wood, and they keep under the soil, you see? And produce, in any case, produce holes, very big holes, that are conductive of water and air into the soil. We are in a vineyard here. Again, this is Lumbricus terrestris. But all the earthworms do the same things? No, only Lumbricus terrestris produce this kind of situation. And other deep burrowing anasic species, I will see here, produce other kind of manufacture. This species endemic of eastern part of Italy, the Collio area, which has the best wine in Italy, live in the forest but enter into the vineyard if you are not very bad with your pesticide use or compaction of the soil. This is about 80 centimeters, you see. Was this described 1888? Since 1972, nobody spoke of it. It's the biggest earthworm living in Italy, but for almost 100 years, nobody cared of it. This is the interest we have about earthworms. This is Octodrillus complanatus. This is also a big earthworm living deep into the soil, making gallery. And this species has been indicated to live in Galilea. And then you have this, but I think only my colleague of Museum of Budapest, Szabad Zici, know it and has collected and documented in this country. This Golan height near Masada. This was Masada in Golan. In the forest, in oak forest. Okay. And see here the galleries in the soil. And organic farming use copper sulfate to fix the problem of fungi. And when you have copper sulfate in the soil, 250 ppm, you have almost no earthworm living there. Then it's a big problem to to fix the amount of pesticide, especially fungicide, used in the vineyards. How to fix the problem? There is technology like this that recover the excess goodlet that can go into the soil. But still is needed much research on this field. And how these are different soil sample of different vineyards in our area. You don't find a sample of soil of the same color of the next. This is dry soil, nothing done, you say. You can see the nuance, different nuance, the many different nuances of soil. Can we protect or deal with this variability of soil? You know how many bacteria we have in this? We have 1,300 genera of bacteria, possibly about 10,000 species. It's difficult to speak species of bacteria, but something like species. And this is the future. We have to study the bacteria in the soil and how these deep burrowing species can affect and modify the population of bacteria in my vineyard. Thank you very much.